The diagram shows a battery of no internal resistance and 4 identical resistors, P, Q, R and S. Resistor Q dissipates 4 watts of power. What is the total power supplied by the battery? Well, because they've told us that resistor Q dissipates 4 watts of power, and we know it's identical to R, so because they share the same potential difference, this should also be 4. Now, we just need to think how these might relate to P and S. And we need to think of what's the most strategic way to find this. Well, we know for power, we can either use P as IV, P as I squared R, and P as V squared over R. So what do these things share in common? Well, they all share the same resistance, and so the only things that we need to find are either the currents going through them or the voltages across them. I think what's easiest here would be to use the currents, because we know whatever current is going through here, through P, would split equally into Q and R, so that would be I over 2. And then this would join back together to make I through S. So we know that I over 2 squared R equals 4 because of Q and resistor R. So this R here would be in reference to all of them. So we have that I squared R equals, well, the 2 squared on the bottom times 4 will become 16. And this is exactly the expression we have for the power in P and S. So we'll have 16 plus the 4 plus 4 plus the last 16. So that is 20 plus 20, which is 40 watts. And that's it. That's the question done.